equations. What does it mean? Simultaneous equations, if I look at last year in grade 10, we had two linear equations. What are linear equations in graphs? Straight lines, yes, straight lines. So if you actually go and sketch these two equations, it will be two straight lines. And what am I trying to solve when doing those two straight lines? I'm trying to find x where they intersect. That x value and that y value will be the values I'm going to get. Not graphically like I just did here, and this is not the representation of those two straight lines, but where they intersect. So what was the technique that you were taught? Get either x or y alone and substitute it into the other one. But you were taught two techniques. Except for substitution, where you can either get the x alone or the y alone and put it into the other one, and you've got choices. But you're always taught to take the easiest route. So here it doesn't matter which one you get alone, x and y, easy enough. This one, if you wanted to go to this one, the easier one would be the y to get alone, and I'll take it to the other side. And then I'm going to substitute it in. I just wanted to remind you about elimination. Elimination was when I look at these two equations and I add or subtract them so that I eliminate one of them. The method behind that is if I put them on top of each other like this, and you don't have to, you can just do it. If I add these two together, this is going to give me 3x.
Cancel.
Boom, eliminated. That's the process of elimination, which doesn't always work, but it did here because of those two that have the same coefficient. So elimination was an option to say, let's take 1 and 2, and what are we going to do with it? We're going to subtract them. Well, no, sorry, we're going to add them. Because if I subtract them, the y is not going to cancel out. It's going to be, if you add them, subtract them, it's going to be plus y plus another y, because minus a minus is a plus, and then it's not eliminated. But as is, if I just add them, I'm going to get 3x eliminated, because plus y minus y when I add them is nothing. Then comes the equal sign, and then I'm adding that and getting 7, and the solution would be 7 over 3. I'm not done with that sum, and I'm not going to finish it. I'm just reminding you of the process of elimination. But elimination in any case only works if I have two linear equations or they both have the same variable. Say for instance this one had a y square and that one also had a y square. Then I could also do elimination. I just want you to put that somewhere in your filing system, because in matric I'm going to show you again. Sometimes it's an option to do elimination, which is quicker sometimes than substitution. So when you're done here, are you finished? No, you've still got to take the x back where? Any which one of them and substitute for x to find the y. What does that mean? That's the point where they intersect the coordinates of x and y. Are you with me on what is simultaneous equations? Yes. So now what's more difficult in grade 11? Now we're not going to work, well, I can still give you two linear equations, but obviously I'm going to test you on still a linear equation, right? Not linear. Something else. And it doesn't have to be quadratic, but usually it is in grade 11, because quadratic is what we've been doing. So if it's linear and quadratic, then out the door goes elimination. It has to only be, what other one that you could do? Substitution. Now, which x and y am I going to get alone? So it's always going to be the linear one that works easier. Always. I can never say that word. Most probably always. Okay? So if I want to get the x or y alone, which one is going to be easier?
Yes.
It doesn't really matter. If I take the x across, it will be plus. But I could just as well take the x across and bring that across and get x alone. Much of the same values. And if I substitute in here, because sometimes I look at this and say, well, it doesn't really matter, but here it might be much easier to either substitute the x because there's less to do, or the y because there's less to do. But this is going to be exactly the same, whether I substitute x in or y in, the calculations will basically be the same. So I'm still going to use the method from last year. I'm going to call this equation 1 and equation 2, and tell the teacher it's marking, what am I doing? I'm going to substitute 2 into 1. Why do I substitute? Because in the place where this straight line and this, by the way, it's a circle, but you don't have to know that for now. But where do they cut? If I want to know where they cut, that's where the x's are the same and the y's are the same. Now I'm telling you it's a circle and a straight line. So they are going to cut most probably at 2 pieces unless it's only a tangent touching at 1 point. That's possible. Is it possible that the things I'm looking for don't cut each other at all? That the line might be somewhere here and I'm asking you where do they cut? You say it doesn't. It's possible, right? Do you think I'm going to test you on something that doesn't cut? Most probably not. Okay, so I'm looking for the point where they intersect. So why, my question is, why can I substitute that y into this y? Because where they cut, the y of the circle and the y of the straight line is the same y. So if I get the y in terms of x in the 1, I can substitute it into the other one. Not for every point, but specifically where they are equal. That's the reason why we do substitution. That you understand why this happens. You get the y alone, and you're saying this y can go right into that one's place. Because at the place where they intersect, they are the same value. So then the sum will be x squared plus. Now y will not be y anymore, it will be x plus 3. So we're changing that y into x plus 3. But the sum stays the same. X squared plus the bracket squared equal to 5. And what sum? I heard it is a FOIL sum. And the rest of it is what we've been doing until it comes out your ears. Quadratic equation, quadratic equation, quadratic equation. The whole thing, just the only thing new in grade 11 is that it's not linear and linear. It's linear and something else. More difficult. Choose the easier one to get into the other one. Substitution is the method to go because you don't have the availability of elimination, most probably. And that's why I'm just going to solve my x. So are you getting this?
Yes.
Why do we substitute the one into the other? Because where they cut, they are equal. The one's x is the same as the other one's x. The one's y is the same as the other one's y, where they intersect. So when I do this, I say, where are they equal? So now, the second step would then be foiling. It's a little bit of a waste of time to write it out, but rather do that and don't make mistakes. So we got x squared plus, read it to me, x squared
plus
3x
plus 3x plus 9.
and I'm seeing a what type of equation here? Quadratic. So what are we going to do? So I'm bringing that 5 across. Earlier or later? Quadratic equation has its rules. Get it equal to 0 and we're going to try factorize after simplification, right? Simplifying that, what do I get? 2x squared plus 6x plus 4. And then I'm going to factorize. First thing I can do is, what am I doing? Divide by 2, so much easier. Or you can James Bond with 2 and 4, it's much easier with 1 and 2. And remember the new calculator will give you your answers as well. So the factors are x plus 1, x plus 2. Then if you think you're finished and you think you're right, double check. See if you time it out as 4 and you still get that same answer. So we're getting 2 answers here. 2 answers of what? Not of 4. X is equal to negative 2. Why are there 2 answers? Because we just said there's going to be 2 cutting points. You didn't need to know that that was a circle, but obviously there are 2 points that they cut. Because there are 2 x values. Now how do I get the y? Substitute which one? Both. For this x, it has a specific y. For this x, it has a specific y. You have to substitute both. Into which one? Please, the simplest one. The linear one is always the best option. So we're going back into equation number 2. So we've got y is equal to x plus 3, or y is equal to x plus 3, and the x is being negative 1 and negative 2. And it's such a long question, I hear Michelle saying. Yes, and you're going to get 6 and 7 marks for it. Right. So when we simplify that, you'll get an answer of 2 and an answer of 1. What does it mean? You're not going to do this. But on a graph, in other words, where x is negative 1 and y is 2, negative 1 and 2 is somewhere over there, and this x negative 2 and y 1, negative 2 and y 1, let's get it on the same height there, would mean my straight line for sure has to look like this. Straight, not a curve, because I know that that's a straight line. The other thing, I'm not quite sure how it looks. It'll look something like that. The meaning is they cut on two bases, where the coordinates are minus 1 together with 2 and negative 2 together with 1. It's still the same basic principle. Get the x and the y alone, substitute it in. Once you've got it, now it's not linear anymore, it's quadratic. Once you've got your answer, so most of the time, how many answers? Since it's usually quadratic together with linear, usually 2 answers. But it can be that it's a parabola that's quadratic and a straight line that just touches on one point. So there could be just one point of intersection as well. Just know what you're busy with. Simultaneous equations is where do they intersect.